In this video, we're going to find the total surface area of a composite solid. The solid I'm showing you here has a cylinder joined to a cone. What I like to do when coming up with the total surface area of a solid is basically to count the pieces I'm going to be adding. I've got a base, so the total surface area will be the base plus, we have a rectangle that's wrapped around a cylinder. So I'm going to call that, I'm going to call that my rectangular wrapper. And then on top, we have the lateral surface area of the cone. Now it's important to note that we do not add the base of the cone or the top of the cylinder because that is where they are joined. If you can imagine yourself as an ant walking on this surface, you would not be able to touch that. So that's what I like to do. I like to envision I'm an ant, and where could the ant walk? And the ant cannot walk in the area where those two spaces are joined. So those are our three parts that we need to come up with. So let's do that. First, we've got the base down here. And that's just the area of a circle, pi r squared. Well, the radius would be 3 because it would be the same radius as where they're joined. We're taking a lot of liberties here. The diagram isn't explicitly showing us right angles or anything like that, but we're doing the basic math here, so we can assume certain things. So that's easy enough to calculate. Here we've got my rectangular wrapper. So essentially what you've got is you've got a sheet of paper that you're wrapping around in a circle to create that cylinder. I've turned it on its side. Let me use a different color. So now we're talking about this. And the height of that, we're going to say, is 7 inches. But what is the width? Well, the width would be the circumference of the circle it's going around. Circumference is 2 pi r. So this circumference is 6 pi. 6 pi times 7 gives us 42 pi as our area inside the rectangular wrapper. Lastly, we have the lateral surface area of the cone. Lateral surface area is pi times radius times the slant height of the cone, which is typically denoted with a cursive L. Well, here's the slant height. We don't have that right away, but fortunately, we're given a lot of parts of this cone. We know the radius is 3 inches. We also know the height of that cone is 4. And if you want to draw that triangle separately, it is a right triangle, and you've got 3 here, 4 here, and we need to figure out L. Many of you might be screaming at the video right now and saying, hey, that's got to be a 5. That's a 3, 4, 5 triangle. Yes, it's a triple. And as we all know, triples are just integer solutions to the Pythagorean theorem. So 3 squared plus 4 squared equals L squared. 25 equals L squared, and L equals 5. If you had that memorized, obviously you would have been able to do that right away. So L is 5. So we have everything we need to fill out our total surface area. We have pi r squared, which is pi times 3 squared, plus our rectangular wrapper, which is 42 pi, plus our lateral surface area, which I forgot to color code, and we're going to make that blue, which is pi times 3 times 5. Put that all together, and we've got 9 pi plus 42 pi plus 15 pi, which is 66 pi. Now, if this was a math problem, which of course this is, that would be enough. 66 pi inches squared. Of course, if you're going to a hardware store and you're going to ask the guy at the hardware store for 66 pi inches squared of paint, or what would cover that, or whatever, that wouldn't be very useful. So instead, we could put that in our calculator, 66 times pi, and he might be more receptive, or he or she might be more receptive to the fact this would be 207.3 inches squared, and then they might be able to help you out a little bit better. But that's how you find the total surface area of this particular composite solid. The point being is that you have to be very careful about what parts you choose and what parts you exclude when coming up with total surface area. It's a lot more difficult than volume. Hope this helped.